This is an application of coordinates geometry. As you can see, we've got a triangle with the vertices A, B and C, and we've got the coordinates of the vertices of the triangle. For example, for vertex A, x is 0 and y is 1. What we need to find now is the location of the vertices of another triangle, A prime, B prime, C prime, which is formed by the altitudes of the triangle ABC. We'll first need to find the equations of the three altitudes, like for example the altitude to BC, which has a gradient that is perpendicular to BC and passes through point A. And then we'll need to find the perimeter of the new triangle A prime, B prime, C prime. The third thing we'll need to find is the location of the point of intersection of the altitudes, which is also called the orthocenter, and prove that the altitude A prime bisects the angle C prime, A prime, B prime. The first thing I suggest we do is draw ourselves a diagram, and we'll first do that by plotting points A, B and C, and then draw the altitudes through A, B and C. And this is our triangle ABC. As we have already said, A has the coordinates 0, x is 0, y is 1. B has x equal to 2, y equals to 5, and C has x equal to 3, y equal to 1. And the perpendiculars on each respective sides are C prime perpendicular to AB, AA prime perpendicular to BC, and BB prime perpendicular to AC. Now, in order to find the equation of CC prime, which is the altitude of C in relation to the side AB, we'll first need to find the gradient of AB. And to find the gradient of AB, we'll use the coordinates of A and B, and therefore MAB, the gradient of line AB, is YB minus YA, YB, which is 5, minus 1, YA, over XB, 2, minus XA, 0. And the gradient is going to be 2. We know that the gradient of a perpendicular line to a given line is MCC prime is equal to minus 1 over MAB. And that means that the gradient of CC prime, the altitude on AB, is going to be minus 1 over 2. And before that we could get the equation of AB, knowing that the gradient of AB is 2 times x plus 1, using the formula to find the equation of a line, which is y minus ya is equal to the gradient of the line times x minus xa. We can use either or of the coordinates of A, or we could just as well use B, because both points A and B are on line AB. but because the coordinates of A are easier numbers to work with, like 0 and 1, I've used those, and I got the equation y minus 1 equals 2x minus 0. So ya is 1, xa is 0, and I got yab, which is the equation of AB, is equal to 2x plus 1. Now that I found the gradient of CC prime, we can use the same formula for finding the equation of a line, and in this case again I'm using the point for which I've got the coordinates, which is C. I know that CC prime needs to go through point C, so I'll use the coordinates of this, and what we get is y minus yc is mcc prime, the new found gradient of cc prime times x minus xc, and that's how we get the, by substituting and simplifying, substituting the values for yc and xc, 1 and 3, we get the equation for cc prime, which is this one here, negative 1 over 2x plus 5 over 2. Now in order to find c prime, the coordinates for c prime, we need to solve a system of two simultaneous equations. The coordinates for cc prime are at the intersection of line AB, which is y equal to x plus 1, and cc prime, which is y equal minus 1 over 2x plus 5 over 2. And making those two equal, because y is equal to y, we get 2x plus 1 equal minus 1 over 2x plus 5 over 2, and solving this we get x equal to 0.6. Now we take x equals 0.6 and plug it in here, and what we'll get is y is equal to 2 times 0.6 plus 1, and we'll get y for x equal 0.6, y will be equal to 2.2. Therefore the coordinates of c prime are 0.6 and 2.2. 0.6x, 0.26x, and 2.2y. Now I suggest after each step of our problem you hit pause and try to do this on your own. We'll do the same thing to find a prime, and again we first find the gradient and equation for BC, which is this side here. We've got the coordinates of the 2 points along this line, which are B and C, and we can find the gradient by saying MBC, the gradient, is equal to YC 1 minus YB 5 over XC, which is 3, minus XB, which is 2. And the gradient for BC is going to be negative 4. Having a negative gradient means that BC goes down from left to right. Alright, so that should be okay by now. The equation of BC is, we can use either B or C. On this line I chose to use C again because I find the numbers for the coordinates of C easy to work with. and y minus yc is equal to the gradient of the line times x minus xc. And substituting the values for yc and xc, 1 and 3, we get ybc is equal to minus 4, the gradient, plus 13. Now the equation of AA prime, which is the altitude perpendicular on BC, the gradient needs to be negative 1 over MBC, MBC being the gradient of BC. And that gives us a gradient for AA prime equal to 1 over 4. MAA prime is equal to 1 over 4. We use the formula for the equation of a line again and substitute the values of YA and XA, which are 1 and 0. And we get the equation for AA prime equal to 1 over 4x plus 1. In order to find A prime, we solve simultaneous equations for BC and AA prime. That's the intersection of BC and AA prime, which is A prime. And we get minus 4x plus 1 is equal to 1 over 4x plus 1. Solving this, we get x equals to 2.824. We substitute this into one of the two equations and we get y equal to 1.706. Therefore, the coordinates for A prime are 2.824x and 1.706y. I suggest you hit pause again and try to do this yourselves and figure out some of the steps I might have skipped in order to get these results. The last one is probably the easiest one. AC. I know that the y of A is equal to the y of C, which is 1. That means that the line AC is a parallel line to the x-axis. So the gradient of AC is YAC minus YA over XC minus XA, which is 1 minus 1 over 3 minus 0, and this becomes 0. So MAC is equal 0, which proves that the gradient of AC being 0, the line AC is parallel to the x-axis. And therefore the equation of AC, I know that this line, which is parallel to the x-axis, goes through points A and C, which have the y-coordinate equal to 1. So the equation is going to be y equals to 1. And BB prime now, BB prime is going to be negative 1 over MAC, which is 1 over 0, and therefore is undefined. And BB prime being undefined, the equation for BB prime is x equal to 2. X equals to 2. So this one here, BB prime, is x equal to 2. And B prime is at the intersection of BB prime and AC. So solving this, we got x is equal to 2. We can simply read this off the graph. X is equal to 2 and y is equal to 1 for B prime. And now we pretty much have all the points of interest. A with coordinates 0 and 1, B 2 and 5, C 3 and 1, C prime 0.6 and 2.2, A prime 2.824 and 1.706, B prime 2 and 1, and if we draw this graph, I used the Desmos online calculator. You can also find this graph at this URL. So you can use Desmos calculator, and if you enter this last bit, TRJUAFVOEO, you'll have this graph and you can play around with it. Question 2. The perimeter of this triangle, this new form triangle, A prime, C prime, B prime, is actually the segments A prime to B prime, A prime to B prime, plus B prime to C prime, plus B prime to C prime, plus A prime to C prime, A prime to C prime, and B prime to C prime. I chose this one because it has easier coordinates to work with, is equal to square root of xb prime minus xc prime plus yb prime minus yc prime, both brackets squared, and that is equal to, we substitute xb prime is 2, xc prime, so xb prime is 2, xc prime is 0.6, yb prime is 1, and yc prime is 2.2. And solving this, we get a result of 1.844 units. Because we don't know what we use here, there are no measurement units, so we simply say units. Now I suggest you hit pause and work out, using the same algorithm, the lengths of A prime B prime and A prime C prime. Now that you've got the results for B prime C prime, A prime B prime and A prime C prime, you can work out the perimeter of triangle A prime B prime C prime, which should get you a result of 5.207 units. That's units of length. Question 3. The intersection of the altitudes A prime, C prime and B prime is at this point here, which is O. I got the coordinates of my Desmos graph, and the calculator says that the intersection of this line should be at x equal 2, y equals 1.5. But I'll use simultaneous equations to see if that's true. And for A prime, I've got the equation y is equal to 1 over 4x plus 1, and for B prime, I've got the equation x equals to 2. I substitute this x equal to 2 into the first equation, and I get y equal to 1.5. Therefore, the coordinates of the orthocenter are at 2 and 1.5. I don't need to check if the other altitude of the triangle, which is C prime, goes through the same point, because I know already that all the altitudes of a triangle meet in a single point. So if I simply use the equations of two of the altitudes, I can find the orthocenter. I don't need to use the third one. And now question 4, which might seem a bit more sophisticated, is actually not. We're being asked to determine whether the line AA prime is the bisector of the angle C prime, A prime, B prime. So if this line splits this angle C prime, A prime, B prime into two equal angles, this and this. Now these angles, the angle beta in our case being the vertically opposite of C prime, A prime, A, and angle alpha being the vertically opposite angle of A prime, B prime, we can work on this side. And I've marked the angles alpha and beta, and I need to prove that those two angles, alpha and beta, are equal, and therefore that C prime, A prime, A is equal to A prime, B prime. I've also drawn a horizontal line here which goes through the point of intersection, which is A, and has the coordinates 2.824 and 1.706 here. And that horizontal has an equation y equals 1.706 because it's parallel to the x-axis. Now, angle alpha is equal to angle A minus angle B, and angle beta is actually angle B minus angle C, this being underneath the horizontal line. Now I know that angle A is the inverse tangent of the gradient of A prime, B prime. So A is equal to 10 to the minus 1 of gradient A prime, B prime. I need to find now the gradient of A prime, B prime, which is y A prime minus y B prime over x A prime minus x B prime. So I use the coordinates of A prime and B prime to find the gradient of this line. And that gradient is 0.8568. Now, I've already said that angle A is equal to tan to the minus 1 of the gradient of this line. The gradient, as you probably remember, is the rise over run. So if we work this out trigonometrically in a right angle triangle, okay, tangent of A is the rise over the run, and A is equal to tan to the minus 1 of rise over run. But we already know the value of the rise over run, the gradient. So A is equal to 10 to the minus 1 of 0.8568, and that gives us a result of 40.59 degrees to 2 decimal points. The next angle I'm going to find using the same logic that the angle B is the tangent of the rise over run B is tangent to the minus 1 of the rise here over 1. And I get, using the same algorithm, I'll find the tangent. I already know that the gradient of AA prime from question 1 is 0.25, 1 over 4. So the inverse tangent, tangent to the minus 1 of 0.25, is going to be 14.04 degrees to 2 decimal points. And now the last one, C, which is underneath the horizontal, y equal 1.706. So C is equals to 10 to the minus 1 of the gradient of C prime A prime, C prime A prime. Alright, so 10 of C is equal to rise over 1. And I get the gradient for C prime A prime equal to 0.222, and therefore C is going to be 10 to the minus 1 of minus 0.222, and that is negative 12.52 degrees. Negative 12.52 degrees. And doing the calculations from above, I get alpha equals to 26.55 degrees and beta equals to 26.56 degrees, which is, considering the estimation of the decimal points, can be considered to be equal. And therefore, if alpha and beta are equal, AA prime can be considered to be the bisector of this angle here, which is the vertically opposite of C prime, A prime, B prime.